Okay, welcome everyone to this course alumni meetup recap. So we did this meeting on spring 2025, and some of you were not able to attend, so I got requests to have a video recording, and you will find the slides also in your email, hopefully. So you can follow the links if they are of interest to you. But what we did during the meeting was that I held a brief talk outlining the main topics of the course and the main rationale, and then we had some discussions around applying these ideas and how we could better support each other in becoming change makers or more successful change makers in our own organizational or other contexts where we are striving to influence matters for the better. So let me first give you an overview of what was it that we did during the course. So I divided the world into these very rough categories, the complicated and the complex. Another thing is that in complicated contexts, you have much fewer challenges posed at you from the environment, and hence you need less or fewer response capabilities. Whereas in complex contexts, there are many more things the environment can throw at you, and hence you need more responses, and for this you need to engage other people, because you as a single individual, no matter how intelligent you are still limited in the amount of complexity you will handle, or which you are able to handle, which will show up as feelings of overwhelm or outright failures. So what I did during the course was introduce this thing called Ashby's Law, and the idea was that we need at least as many responses to challenges as we are posed by challenges. So in this sense, here's, by the way, a very nice piece. It's already quite old, but every year something happens, and I read it again and find myself thinking that this is again very pertinent and contemporary. Okay, so I presented this sort of a diagram where we have the number of challenges the environment can throw at you here, and the number of your responses on the vertical axis. Another thing is that if you have this many responses, but the environment only produces this many challenges, then you end up here. And you will succeed in encountering those challenges. Whereas if there are this many environmental challenges, and you only have this many responses, you end up below the diagonal, and you will encounter some sort of a failure to respond to whatever the environment has chosen to throw your way. And we have this diagonal here. So if we are somewhere here on the matrix, then we might have many responses, but many of those will be redundant because they are not of use in the current environment. They might be useful later, but they might keeping those options open might also cost money, resources, something like this, and so you might not So you might be acting wastefully in some situations if you are here on the top left portion of the graph. So the optimal place to be would be somewhere here, but we don't want to dance on the cliff of chaos, and well, depending on how you interpret those terms, you might disagree a bit, but it might be good to have some redundancy here, so end up somewhere here, so you're not wasteful, but not encountering failures either. And now the issue is here that across time, the environmental demands, the world grows more interconnected or interconnected in a clustered way, as we now see with China and Russia, the dragon bear dynamics, where they are getting networked, and the US might or might not become more sort of networked internally and less externally. Who knows what's going to happen? But anyway, the thing is that the complexity of the operating environment tends to grow, and hence you need more responses. So you are in a sort of a Red Queen's race, and will need to increase your responses over time to follow the increasing complexity of the environment. And how do we do this? During the course, I presented this idea where you have a hub who gets, so this is a person whose desk, so a problem lands on their desk, and they decide, oh, it's a problem for the blue expert, and they divert it to the blue expert. It's a problem for the yellow expert, and so they give it to the yellow expert, and so forth. And so we discussed that, so this is from this link, the text. So we can solve, if each of one can solve 10,000 problems, then these will together solve 10,000 plus 10,000 plus 10,000, so 50,000 problems in total. But now if we are actually in the complex context where the environment is throwing many, many more challenges at us than in the complicated context, then we need something like this, where these people are working together in order to produce this multiplicative dynamic, so everyone can solve 10,000 problems, so we can solve many, many more things than in the specialist independent case. And I'm often thinking about the old Native American saying that if you want to go far, go. If you want to go fast, go alone. If you want to go far, go together. So this is basically what complex system science tells us. So the complexity is increasing, and we need to increase this way of networked working together. But the thing that complex system science doesn't say is, what should we actually do? And this is where these sense-making practices and social psychology have something to offer us. So we had this Venn diagram where we had the applied social psychology and practical behavior change science, complex systems science and risk management, and thirdly, the sense-making, which is producing these responses that leverage the wisdom of the crowd or the swarm intelligence. And so we want to be here. We want to draw from this and this and work efficiently together. So just to recap, so complexity increases, hence we need more responses. We need more, to have more responses, we need more viewpoints. We need more people who are not us, because our history is path dependent. We are sort of stuck in our own histories and narratives that we grew up with. And hence, we need many people from our organization. We need these engagement and inclusion practices, and we need to have these not only have diverse people, but we need to have them work together efficiently to be able to make sense of situations together, and hence this idea about sense making. And this produces an interesting question on what is going on with the recent Trump administration on trying to tone down these initiatives about diversity, equity, and inclusivity. Do they lead to a lessened capacity to respond, where we have these, we end up with these more homogeneous groups tackling problems with the same ideas that have worked in the less complex past? I do not know, but it seems like a very important question to think about. Now, I've told you I reduced the world into two very rough categories, the complex and the complicated. And we have a sense-making framework that we can use, which is the Cynefin framework. So this is pronounced Cynefin, not Cynefin. It's a Welsh term meaning the place of all your belongings. But the basic idea is this. So you have you have four domains. So three here and a central domain. And here on this side, we have something that's called ordered. And the ordered domain can be divided into two, complicated and clear. So in a clear environment, or a clear situation, a clear context, it's quite obvious what is to be done in a way. So whereas we could say that the healthcare system, for example, it's a complex system, we have some things, so the beauty of this framework comes from having these discussions. So someone in a meeting might say, oh, well, the healthcare system is complex. And then someone might say, well, it's not all complex. So for example, when a nurse needs to go to the toilet, it's quite clear what they should do. And then someone else might say, well, it's not that clear because we have these time pressures and these procedures. So if they go to have if the nurse goes to the toilet when they are needed on the round with the patients, then that's going to cause problems later on. So there might be a complicated aspect, which is a domain, a subdomain of the ordered world, where experts can solve a problem if they analyze it properly. So it might be possible that actually we produce these schedules which enable the toilet breaks for the nurses or doctors for that case. So in clear situations, we observe what's going on. Then we categorize it into a category of stuff that we know how to respond to. So every time, so we have certain things that work pretty much every time. If we're hungry, we eat. If we're thirsty, we drink. And so if we see a problem and we categorize it, oh, it's a hunger problem, so we can go and have a snack or something like this. And it's quite clear, everyone knows this. But then we have these complicated issues where we actually need to have specialists who work out and analyze the situation. So they observe what's happening, they analyze what's going on, and they respond by coming up with a solution that they pretty much know will work. And it's ordered because there are many constraints at play. So in this sense, these domains are based on the language of Alicia Huarero, who has this constraint-based definition of complexity. She later, in her newest book that came out last year, Context is Everything, it's called, she produces a typology of constraints and uses the words a bit differently, but early Huarero used this terminology where the ordered world could be, or ordered situations could be characterized by such that the clear constraints, clear situations have fixed constraints. So there are these things that enable action that actually are quite stable and very fixed. So by constraint, we don't mean anything necessarily negative. So, for example, queuing conventions in an ice cream stall, they have the queuing convention, the habit, the social norm is a constraint that allows us to buy ice cream, and it might be different from one place to another. So, for example, in Cuba. What you do is when you go to an ice cream stall, you don't see a straight line with people standing behind each other, but you actually find a mess of people, and then you need to figure out who is the last person in the line. It's been many years since I was to Cuba, but I think they might have shouted. You might have to shout something like "El Ultimo" or something like this, and then someone raises their hand and to indicate that they are the last person on the line, and then. After that person gets their ice cream, you know that it's your turn. So there's also a social aspect there, but it's a constraint, but it's different from the many Northern Atlantic conventions in Europe or the North America. In complicated contexts, the constraints are what we call governing. So they sort of create bounds around some situation to make it more palatable. And then we have so both of these two remaining domains here on the left side are unordered domains. And the first one of these is what's called complex, and it's not complex in the way that, so for example, Janir defines complexity in the multi-scale manner based on the complexity profile, but it's complex in from the applied complexity or the antral complexity perspective, which is defined by the constraints. So the constraints are, instead of enabling or fixed or rigid, the constraints here are enabling. So not governing, not fixed, but enabling. And so there are certain things in the environment and in the situation that enable stuff to happen, to build on, to scaffold. So we have maybe more scaffolds than actually these clear boundaries. And in a complex context, what we do is that we don't analyze, then implement, or categorize and then implement, but what we do is probe. We do an experiment, we do something and see what happens, and then we try to accentuate the positive and diminish the negative. And in this way, what Donella Meadows often says is this idea of dancing with the system. So you do something, you see what happens, and then you respond. So this is also, we can see in world politics, we can see many people doing this, like Putin, for example, has been particularly successful in causing these different situations to arise, watching what happens, and then capitalizing on what to other parties might seem as chaos. And the people around Donald Trump are also very good in doing this. And then the second part of the unordered domain is called chaotic, and it's not again the same language as in chaos theory, but or mathematical chaos, but it's more an absence of constraints. So there, like anything, basically can happen. So once you are in a chaotic situation, what you might what you do is you try to stabilize the situation in order to go to the complex domain, or you might want to go to the middle domain. We'll mention that briefly next. But once you're in the complex domain where you can sort of do these experiments, you can try them out. Maybe at some point you figure out that, hey, every time I do this thing in this situation, it works. And then you might find yourself moving from the complex situation in this particular regard towards a more complicated situation. So you know that every time I do X, Y happens in this particular context that I'm dealing with. And so we know that if we get the right data about what the situation is like, maybe we can analyze the right response and be successful. And then at some point, the environment might change, and we might need to go back to the drawing board, back to doing experiments, or maybe even loosen up constraints and have this shallow dip into chaos before we move. So this is move back to the complicated. So this is one of the Cynefin dynamics. There are many more, but I won't go that much into it. But at some point, you might find something that you're so confident about that every time this happens, you do this. So, for example, you might have this situation where maybe you're building a self-driving car, and it categorizes itself that, hey, I am in I'm in the UK, so I will drive on the left side of the road, or I am in Germany and I will drive on the right side of the road. And you will have this fixed constraint. But now the problem is that when there are exceptions, you might, so maybe someone runs on the street in front of the car, and your algorithm doesn't allow this exception, then you might fall. So the shadow here is meant to represent a cliff. So you might fall down the cliff into a very chaotic situation, and you usually can't go back from the chaotic situations to clear, but you need to go all the way back to this dynamic here, perhaps. And the middle domain is quite important. It's called aporetic, which basically represents a situation where we know that we don't know where we are. And so this is where sense-making processes tend to start. And there are many versions of the Cynefin framework, and there is a lot to discuss about this, but we won't go beyond this shallow dive today. And then during the meeting, I was also requested to talk about ergodicity a bit. And so what I did was whip up these slides. And so basically the idea of ergodicity, and this is mostly interest of you if you are in research perhaps. But so for example, Luca Delana has a book called Ergodicity, and that's a very good book if you want sort of more generic, not nuanced takes on what ergodicity is and what it means for the everyday life. But from a research perspective, so this is called the Cattell's data box. So each row here is one individual, and each column here is one variable, and here we have time points. So what we often do when we do social science research is that we take many individuals, or what we have done in the past is take many individuals, ask many questions, or take many physical measurements of them, and out of one time point. Or maybe you have an intervention where you have the baseline, and then you have a mid-intervention follow-up, and then you have sort of the long-term follow-up, like some months or years after the baseline, to see whether the control group and the intervention group differ from each other. And another take that has been growing very fast during the last decade or so is this sort of more individualized perspective, where in the extreme case you would take just one individual, make many measurements out of that individual, and include many time points. So you can actually look at the individual's dynamics and how the individual variables are coupled in time and affect each other. And if these two produce the same results, you're dealing with an ergodic system. I will go through a couple of more examples, but the basic idea is that in an ergodic system, if you take the average of one individual over 100 days, you will get the same result as you would get if you measured 100 individuals on a single day. In an ergodic society, you might have 100 professions, and every person would spend 1/100th of their lives in each of the professions, which obviously is not true. And this is also a fact that almost all factors of the social world are non-ergodic. As a researcher, it's so much easier to have 100 people measured once than have one person measured 100 times. So it would be nice if things were ergodic, but alas, it's usually not the case. And now the question becomes, how non-ergodic is it? So how big a problem that is? And this is a question that's been surprisingly little discussed in physics literature, for example. So when we have a non-ergodic situation, we can't generalize from group level data to individuals. And just to give a sense of how this creates some unintuitive situations. So imagine yourself throwing a coin. So you start with a bet of 100 euros. And so now you have 100 euros. And in this game, if you land heads, you win 50%, so you go to 150. And if you get tails, you lose 40%, so you end up with 60 euros after the round. And this has a positive expected value, so it it would be sort of from a group perspective, it would be a good thing to play this game because you win more than you lose. And now let's think of a situation. So think of yourself and three friends of yours. So you play this game, and so the first person, your friend, has heads. He goes to 150. The second person also runs heads or flips heads, goes to 150, and you and another unfortunate person go to 60 euros. Okay, so what happens next after in the next round? Well, if this were a like an ideal situation, this person would again win 50% if they run flip double heads. This person would go back to 90 euros, and as with the tails heads case and the tails case is back is losing quite a lot of money here. Now, what you might observe here is that if you calculate all these numbers together, you end up with a total wealth that has increased. As was intuitive when we looked at, okay, so wins are more than losses, so total wealth has increased. But actually, most people here are worse off. And this inequality worsens if the game continues over time, and particularly when you have many people playing the game. And this is why, so there's Ole Peters, so OLEPETRERS. He has he's a physicist who has been working on economics, and he has written about this quite a bit, and also like a solution why in these sorts of situations it would make sense to actually pool the money and spread it over the participants after each round, so everyone would be actually better off. And he shows that in his paper, in one of the papers. But I highly recommend, if you're not interested in the mathematics, to look at this book by Rory Sutherland. So this example is from the book, and it's quite a wonderful and engaging read. So the last example, so if you imagine that someone would offer you to play Russian roulette for 1 million euros. So in Russian roulette, you have a revolver with 6 chambers. You put in 1 bullet, you flip the base with the ammunition, so you don't know if it's going to be deadly or not, and then you put it on your head, and you flick the trigger. And so now you have 5/6 chance of winning 100 million. And imagine, would you take this bet? And usually when I give this example, one or more people raise their hands. But when I take the sort of seemingly equivalent situation where you would do this 10 times for 10 times the money, no one would actually do this. And the reason is that the individual level outcome is widely divergent from the group level outcome. So if 100 people would do this once, it would be very different than one person doing it 100 times. And then I have an example about correlations. So if you would have one person being measured on 2 variables on 100 days, if that would equal 100 people correlating just a single day's variable over time. So if this would match this, then you would have an ergodic system, and this is almost never true. And here are some final things to look at if you want more further reading about these topics. And I included the quote by Michel de Montaigne here. We can't often in these social situations, we can't follow many people for a single step, but we actually need to trace a single person, or hopefully many people, for many steps. And this is also how you deal with the complex situation in the Cynefin framework, where you see the dynamics that arise and the doors that open when you take one more step and one more step, and then you react. Okay, so this is where I ran out of battery, but all that was needing to be said has been said. Expect for the fact that I really hope we can continue having these meetups and building the community around understanding and changing complex social systems, because we had very interesting discussions during the meetup, and I really would hope to keep those up, because you never know what emerges when people get together to discuss interesting topics. So next time I hope to have a little shorter presentation, and maybe we can do some hands-on stuff trying to figure out a real problem maybe that we might be facing. So I hope to see many of you next time in the alumni meetup, and until then, have an excellent spring, you all.